everybody, and today I'm going to tell you about a very scientific topic called immovable objects. So, now we have two imagines. Actually, a few more, of course. First, imagine that you have this pen, okay? You put it on the table. You roll it. It's a movable object, right? But imagine if you're like this, straining. Yeah. You're trying to push your house. You say your house is an immovable object. Wrong. Let me explain. Imagine you are riding a motorbike. You are riding it along the house, around the house. You see the house at a different perspective, like it's a spinner. It's spinning around really slowly. But what do we actually call immovable objects? They are called unacceleratable objects, which means that they can accelerate. Let's move back to the motorbike. When you pull the gas part of your car, of your motorbike, or you press the accelerate pedal on the bottom of the car, they will accelerate, which means it will move forwards. Unacceleratable means it cannot move forwards. For example, this. I cannot move it forwards, but it can move it backwards, which means I'm pushing the board back onto the wall. Very interesting, right? Now let's move on. Why? Every millisecond, the radiational level inside your body changes a teeny tiny bit. This is because when light travels to your body, it will transfer electrons into electrons, or gluons into gluons. For example, our body is a gluon, and the light is transferring gluons, so the radiational level of our cells changes very little. Or if our body is an electron at the moment, and the light and the light passes electrons, then the radiational level will also change, but it changes a little bit more, about 2/3 or 4/3 of the radiational level when gluons travel. So how don't you have your radiational level increased? First, this is the first one. Rub your whole body against a rug and look at a light where it's transferring gluons. The gluon will simply bounce off or pass the electron's body. Or you could swerve your hands so that they could gather gluons. When they gather gluons, go to a light that has electrons and get the electrons to flow down to your hands. Then the radiational level of your hands won't change, but the rest of the body will. So, to conclude up this lesson, immovable objects are acceleratable objects. That is true. Immovable objects are objects that cannot be pushed or moved. Falls through the two explanations. The first one the first truth is because that unacceleratable object means you can't move the object with a normal standing perspective, no movement. It's like a movable object. after the second explanation, immovable object. Immovable objects are objects that cannot be moved. That is false. Because if you're adding at a 360% circle around the immovable object, you will see that it kind of swerves or spins in a direct angle. Okay, so that is the end of my lesson. I hope you like it.